Hello everyone, welcome to Coding Decoded. My name is Sanjay Rodeja. I am working as Technical Architect SD4 at Adobe, and here I present the weekly contest 299. The first question of the contest is check if matrix is X matrix, and if you are looking for rest of the questions, all the solutions are mentioned in the description below, so do check them out. But let's focus our attention onto 2319 for now. A square matrix is said to be X matrix if both the following conditions are met. All the elements in the diagonal are non-zero, so the diagonal elements are non-zero and rest of the elements should be zero. So we are given a matrix where if these two constraints are met, then we can say that it's an X matrix, and therefore we should return true in those cases, otherwise we need to return false. Now let's quickly walk through the presentation section where I'll explain the algorithm. Leetcode 2319, check if the matrix is X matrix, and in case if you have any doubt understanding this question, or if you want to ask anything from me in general with respect to placement, internship, job opportunities at Adobe, please feel free to drop a message on the Telegram group or the Discord server of Coding Decoded. Both the links are stated below. Now let's get started. Here I have taken the same example that was specified in the question, and as per the question, a matrix is said to be X matrix if all the diagonal elements, so let's go ahead and highlight the left diagonal, and here you will see that all the elements are non-zero in nature. Similarly, if I go and highlight the other diagonal, the right diagonal, then again you will see all the elements are non-zero in nature, and the remaining elements are zero in nature. That simply means both the constraints are fulfilled and we should be returning true in those cases. The problem reduces to whether an element is part of the diagonal element or not. So let's try and analyze all the elements that lie on the diagonal. So for the first one is a left diagonal. So if you carefully see, then the ith coordinate and the jth coordinate for the left diagonal happens to be equal. So here it is 0 0, here it is 1 1, here it is 2 2, here it is 3 3. And now it's time to analyze the rightmost diagonal, whether we can draw any mathematical equation out of it. If yes, then our work is done. What we will do, we'll iterate through the entire matrix and we will check if the current element is part of the diagonal element. If it is, then it should be non-zero, otherwise it should be 0, and if any of these constraints are violated, we'll simply return false in those cases. So the problem reduces to identifying the elements that lie on the left diagonal and the right diagonal. Left diagonal we have already done, right diagonal we are looking at. So if you carefully see, then this element which is on the right diagonal, I coordinate is 0, j coordinate is 3. So 0 plus 3 gives you 3. So I plus j gives you 3. Let's proceed ahead, and the next element is this one. Again, I plus j, 2 plus 1 gives you 3. So the constraint is again fulfilled. Let's proceed ahead. Next, 2 plus 1 gives you 3. Again the constraint is met. And the last one is 0 comma 3. Again the constraint is met. So we can say that if I plus 1 happens to be equal to n minus 1, where n signifies the number of rows / columns in the matrix, then all those elements would lie on the right diagonal, and for the other diagonal, the ith coordinate should be equal to the jth coordinate. This is how we will identify any element that lies on the diagonal. Without further ado, let's quickly walk through the coding section and conclude it up. So here I have iterated over the entire matrix. I have created a helper method wherein I am passing 3 parameters, I, j, and the total number of rows / columns that I have. And in case the helper method tells it's the current element is a diagonal element, then what do? I check whether the value at that current element happens to be 0. In case it is 0, that's again a violation of the first constraint. We should return false in those cases. Otherwise, if the current element is not a diagonal element, what do? I check whether the value at the current element happens to be non-zero, opposite of the constraint. So if that is the case, that means the constraint is violated and I return false in those cases. Once I am done with this loop, I simply return true. If these conditions are not fulfilled, then that means it's an X matrix. The problem reduces to writing the is diagonal method appropriately, and we have identified both the constraint I equals to j and I plus j is equal to n minus 1. So if any of these are met, that means the current element at I comma j index happens to be a diagonal element. So let's try this up. Accepted. The time complexity of this approach is order of n square. The space complexity is constant time. We are not using anything extra. Thank you.